Okay, guys, example 3, letter B. All right, so remember again, we're still doing unusual solution sets of those nonlinear inequalities. And so just like the others, we have to make sure there's a 0 on one side of the inequality symbol, which there is. And then we got to find those x-intercepts and vertical asymptotes. So remember, we find the x-intercepts by factoring. So we need to make sure that the polynomial here is set equal to 0, and then let's factor that. So we end up with x plus 2 times x plus 2, and we make both of those equal to 0, so they're the same. So I just solve that one, and I get x equals negative 2, and again, because it was there twice, we have multiplicity of 2. Now, for the vertical asymptotes, remember, that is where the denominator, the uncancelled factors of the denominator is equal to 0. We don't have a denominator, so we don't have any vertical asymptotes. And again, we're ready to set up that interval table. Okay, now that we get the basics of our interval table set up here, let's go ahead and let's set up our intervals. Remember, they're broken up by the x-intercepts and the vertical asymptotes, so negative 2 is the only thing that's going to break up my table. So my interval goes from negative infinity to negative 2, and then negative 2 to positive infinity. Infinities always get parentheses, and I look in the problem here and I see, oh, this one has an equal to, so that means that the negative 2 is actually going to get a bracket. Remember, that's only for x-intercepts. Later, when we get to vertical asymptotes, they'll always have parentheses themselves. All right, so let's pick an x value that's in our interval. So let's say between negative infinity and negative 2, we pick negative 3, and between negative 2 and infinity, let's pick 0. So when we plug the negative 3 into our given function, we see that it is 1, and when we plug in the 0, we get 4. Both of those are positive. And so remember, let's go back and let's look at our problem. We want where it is less than or equal to 0. Well, where is it less than 0? These are both positive. Therefore, we don't have anywhere that it's less than 0, but do we have where it's equal to 0? Well, that's where my x-intercept comes in over here, because this is where it was equal to 0. So I do have a solution here, but my solution is only at the negative 2, because that's where it was equal to 0.